Hello everyone and welcome to the next topic on probability. I think many of you may be familiar with some probability questions. For example, what's the probability of rolling below a 3 on a fair 6-sided dice? We know that this probability is just 2 over 6 based on basic probability rules. Basically, the probability of a certain event A happening, which I write PA in mathematical notation, is just your number of sample points in A over your total number of sample points. So to find out the probability of my dice roll rolling below a 3, I first find my number of sample points. And in this case, I can only roll a 1 or 2 to get below a 3. So my number of sample points is just 2. And my total number of sample points is 6. And that's how I get my answer of 1/3. Now the next rule we're going to be learning is the complement rule. What this says is that the probability of A happening is equals to 1 minus the probability of A prime. Now if we look at this Venn diagram over here, epsilon over here represents the total sample points. Now let's say I have this event over here, A, colored yellow. A prime will just be this blue part, which is everything that is outside of A. So the probability of some event A happening plus the probability of A prime will equals to 1. And why 1? The total probability is just 1. You can't have a probability of greater than 1. Now the next thing we're going to look at is the addition law. Before we start on this, if you're not familiar with A union B and A intersect B, let me show you what it is on the Venn diagram. A union B will just be this entire thing over here. It's taking all the points in A and B together. A intersect B will just be the part where A and B both intersect. So only any points where they overlap. If we look at this, we can derive a certain formula, which is the addition law, and this is in your formula booklet. The probability of A union B will be equals to the probability of A plus the probability of B minus the probability of A intersect B. Now if you look at this, the probability of A is this yellow thing, plus the probability of B, which is this blue thing. And if you look at this, we're actually double counting this part in the middle. So if we minus the probability of A intersect B, we will just get probability of A union B, which is this whole red thing. In English, this actually just means A or B happening. And this means A and B happening. So if you see something like this or this in your question, you will know how to match it to mathematical notation. Now let's try a question. Find P of x union y prime given that Px equals to 0.6 and Px union y is 0.95. What I want you to see is what x union y prime is. X union y prime is just this entire yellow segment over here. If you look at this yellow segment over here, I'm including stuff from x, which is this blue thing over here, and y prime, which is everything that's outside of y. So the union of x and y prime will just be this yellow segment. Now if you look at this carefully, I can split this yellow section into two parts. This part, which is inside x, and this part, which is outside both x and y. And for this red part that is both outside x and y, what I can say is this is just P x union y prime, because this is outside of x union y. Now we know that Px is just 0.6, but what is Px union y whole thing prime? By the complement rule, Pa is equals to 1 minus Pa prime. So in this case, if we take A as x union y, then this will just be 1 minus 0.95. And this just equals to 0.65. The next thing we're looking at is independent events. This is a specific type of events. So two events are independent if PA intersect B is equals to PA times PB. Again, this is only for independent events. What does it mean by events are independent? This means that they do not depend on each other. So for example, I can say person A rolls a dice and then person B rolls a dice. The outcome of this event over here does not affect the outcome of this event over here. For non-independent events, there's this thing called conditional probability. This formula is expressed as P A given B. So what's the probability of event A happening given that event B has happened? And we get this as P A intersect B over P B. Now let's say I have two events. Over here has HIV and the second event HIV test. Now here, what this means is that 1 over 1,000 people have HIV and 999 out of 1,000 people do not have HIV. Now if I want to say P as positive and N as negative, then what this arrow means is that 90 out of 100 of those who have HIV test positive for the HIV test. And over here, 10 out of 100 of those who have HIV test negative on our HIV test. Now this 90 over 100 over here represents the probability of a person testing positive given that yes, the person has HIV. And that's why I write in this notation over here. Similarly, let's say for no, this means that the probability of a person testing positive given that he does not have HIV is 1 over 100. And over here, the probability of a person testing negative for HIV given that he does not have HIV is 99 over 100. This over here is what we call a tree diagram, which can very easily help us represent probabilities when we have more than one event. Before we do this question over here, let's do something simpler. What is the probability of a person having HIV and testing positive for the HIV test? So using this formula over here, I can write that the probability of a person, yes, both testing positive and actually having HIV, which can be written in this notation over here, will be equals to the probability of a person actually having HIV multiplied by the probability of the person testing positive given that he does have HIV. So to find the probability of a person having HIV and testing positive for HIV, we will take the probability of a person having yes, which is this over here, multiplied by the probability that a person tests positive given that yes, he does have HIV. And that's just 1 over 1,000 times 90 over 100. Now let's go over to the big boy question. What's the probability of having HIV given that the HIV test is positive? So we're finding the probability of having HIV, yes, given that he tests positive. Note that this and this is not the same thing. So if we utilize this formula over here, we'll get P, yes, he has HIV, intersect with him having positive for HIV, over the probability that he tests positive for HIV. Now the first one we did earlier already, this is just 1 over 1,000 times 90 over 100. We're just taking this times this. Now if you want to find the probability that he tests positive though, we need to look at these two. So the total probability that he tests positive, not relating to whether he does have HIV or not, has to be this times this plus this times this. So we add up all the roots to get to positive HIV test. And after I compute this, I'll get 10 over 121. As you can see, this number and this number is very different, alright? Here's the summary sheet for probability. Thank you so much for watching.